All right, good afternoon, everybody. My name is Martin. I'm from the YNU's Estuarine and Coastal Engineering Lab. And today we have a brief look into coastal engineering. And if you don't have much familiarity with it, hopefully today's small lecture will give you some insight or some look into it. And the main focus will be about climate change or how climate change relates to coastal engineering. So first, about the definition of coastal engineering and what it really is. There's many you can have broader definitions, you can have longer definitions, but in its essence, it involves in designing and building different types of coastal structures. And this is to protect from either natural hazards or to also provide different types of services along the coastline. So one of the best examples, for instance, is ports and harbors. And the ultimate goal of it is to develop sustainable and effective ways to protect the coastal environment, to protect the humans. And yeah, that's the sort of definition in a very short glance. But if you look deeper into the subfields in coastal engineering, we can see that there are many different subfields. And some of them, are related to pure engineering, some are a little bit more science, and you even have social sciences in here. And when we talk about climate change, it becomes increasingly more important as well to include those aspects. And there are many different fields, and as we mentioned, smaller fields. And some of these smaller fields can even be categorized into more specific subfields. So, instance, we have in coastal hydrodynamics. But what is coastal hydrodynamics? And there's lots of different studies and research areas specifically in that side as well. So, for instance, what we are also very interested in is wave and coastal structure interactions. And there is also a lot of fields that we combine with non-coastal engineering sites. And again, when it comes to, for instance, climate change parts, very important here as well is aspects from atmospheric sciences. And even when we design structures and things like this, then different parts of civil engineering also come in here, like concrete, structural, geotechnical engineering, and even urban planning, because these days we try to make the coastal space even more attractive to people as well. So you have recreational activities and people can do things in the coastlines. And a lot of the things in climate change and adaptation also come in is, as mentioned, is the sort of social aspect of this, or like we call it like sociology or anthropology, or how people interact with the coast itself. And various connections exist between those different subfields. And in YNU research group, broadly speaking, we could put, with the orange ones in here, the different activities to larger extent or to smaller extent that we are involved, and some of these things even develop as we go on, and different research is needed to being done. And specifically about climate change, for instance, again, you can extend this list or these different subfields even to a greater extent. But here is just some examples. And on the red one in here as well, we have, I think, is the coastal climate change and adaptation. And these days it's becoming more increasingly bigger topic, and a lot of talks are around this issue. So, but what is climate change and why do we care? So essentially, there's many different parts to this, but at its core, it's the increase in Earth's atmospheric temperature, for instance, and also temperature changes in our oceans. And this changes everything, rain patterns, storms. Some places we have stronger storms, or maybe the storms are going north. So it's changes in storm tracks as well, and floodings. And it has various types of effects on the coastal areas. And one of the biggest topics that today we're discussing about is the rising sea levels. One moment. Sorry about that. And yeah, rising sea levels, increases in floodings or storm surges, typhoons, for instance. In Europe, we talk a lot about extratropical cyclones. So these are like winter storms. And it has various effects on the human systems or humans in the coastal lines and also for the natural systems. And usually the people who are most affected by this are low-income communities, for instance, or nations, and especially in low-lying areas. So in a lot of the tropics, for instance, like the deltas and coastlines and smaller islands, they are very low-lying and flat. And these are the areas that are most affected by these climate change effects. So, and a lot of things are already happening, and a lot of the things we're already seeing. And in some places we call them climate refugees, for instance, is from the rising sea levels. And in the graph in here, you can see there's a chart in here. And it shows the projections for atmospheric or surface temperatures globally. And these days we talk a lot about, okay, if the global climate change is 1.5 degrees, 2 degrees, 3 degrees, and then what are those effects on us as humans or our natural environments? And here are also some of the few questions that we're very interested in. And a lot of it comes down to sort of predicting the Earth system, how well we can predict it and how well we can sort of study and prepare, plan for the future itself. And in here as well, actually in the past slide, we talked about, brief mentioning, it was about IPCC. This is International Panel on Climate Change, and it's sort of like, for the people who deal with climate change, this is sort of like the Bible. And it is the most up-to-date documentation about what is happening, what do we know, and where we should be heading in the future. And here is like a brief summary of this, or some sort of like a policymaker's information. And again, when we talk about sea level rise or global mean sea level rise, so it has been now identified that the main cause or the main sort of driver, so to speak, for the mean sea level rise is actually from the melting of glaciers and ice sheets. So this is usually in higher elevation areas, and especially when we talk about North Pole, South Pole, Arctic, Antarctic. And there are a lot of different projections for sea level rise. And you can even see that there's lots of unknown about the future. We don't know how much it's going to rise. So that's why we also have different scenarios. And different scenarios in the future is like if we continue burning more and more, we have different outcomes. But the climate system is very complex and predicting future is difficult. So we have a large sort of spread. And it could be anywhere from like 0.4 meters to 1 meters, or some estimates are even much more extreme, and they have even maybe some ranges close to 2 meters and even more than that. So what are some of the impacts from this? One example is the Arctic. Arctic is one of the places that feels the climate change effects the most. And we can see this, and it has been happening for years now, is from coastal erosion. And one example of this is a small port hamlet. It's called Tuktoyaktuk in northern Canada. And it's facing the Arctic Ocean. And they have lots of problems with erosion and sea level rise in there as well. And in this graph in here, you can see that in the, I believe it was 1950s, this white line is the original coastline, and how over the years it has been sort of eroded away. And it's a big problem in there, and the local communities, for instance, are using different types of local materials. They have been trying to use them, but they don't necessarily work very well. It just takes one big storm, and then this local protection system is gone. But building proper coastal defensive systems around these strategical coastline parts is also very expensive and the area is very remote. Another example is from Indonesia, and I believe I cannot even pronounce this name. It's a Karangchaladri village. And it just shows an example how different types of solutions, again, locally are being used. And in this case, for instance, coconut husks. So this is sort of form of bioengineering, or like making a bioengineered seawall. And the idea over there as well is to using local traditional or like local resources, what we have in hand. So it can be sometimes bamboos even, and in this case it's coconut husks. And they try to grow plants in here, and hopefully this will sort of make the coast a little bit stronger in that area. But the effects of this long term are still not known. But these bioengineering solutions we can talk a lot about next time. Another example is the island of Mauritius. This is in East Africa, and this one is also experiencing a lot of coastal erosion problems, and these are becoming recently even more serious. And from this map even, you can see that it doesn't matter in what location you are in the island. Is it north, south, west, or east? All over the place, there's different erosion types of problems happening faster and faster as well. Here is another example, and this is from the local place, Japan, and this is Nemuro City. And this is 2014, there was a winter storm, and it also caused a large problems or flooding in Nemuro City itself. And one thing as well, what we can do is we can study those past events and past disasters. So for example, here we do simulations or we do computer models, and we try to recreate the history and trying to identify which areas, when the city is flooding, for example, are more dangerous. And here you can see there's different types of, these are current velocities. And there are some areas where you have very high current velocities, almost like up to 10 meters per second. And then we try to understand, okay, if we have these more dangerous locations, or what is even the impact on humans, especially, for example, children and the elderly. And here's another map that shows that with the higher colors in here, it becomes more dangerous for humans in those areas. But there are many challenges with these types of research and studies, and we also continuously try to find ways that we can extend it and improve our understanding. But very important is data. And the problem is lack of it. There is no good data often in one of those like most vulnerable places. Arctic, almost no data at all. It's very difficult to get good data. Image on the left bottom here shows that there's large gaps in the data set. Another thing is our representation of topographic data is also, again, very important for modeling, for adaptation design. And if we use satellite data, which we mostly do, it can misrepresent the actual situation in those small lying areas. So recently, again, it's very important to have high accuracy data to better study these different types of locations, for instance, phenomena. And another one here is, for instance, in Myanmar. So there was a big cyclone, and in the Bay of Bengal, we do have cyclones in there. But there's, again, almost no measurement data sets. And one way to sort of find a solution for this is satellites. And we can sort of estimate, we can model those wave conditions, and we can also get and verify them, or try to see how good is our simulation with the satellite data. It's still better than nothing. And there are many methods to study these things in coastal engineering. And we use various different types of methods, numerical models. We try to model or simulate the atmosphere, the ocean, waves. satellite data, as we just talked about, for water quality or for using in areas where we don't have data. Field data, where we go and take the data ourselves and collect it. We also very much need to study the past. Understanding the past in any location is very important. And there's also laboratory experiments. However, sometimes these engineering solutions can be very clear, but in reality, things are much more complicated. And they become more complicated as well from different aspects. And this considers like policies, government policies, local government policies. What is the culture in this area? Is it feasible? Can we do it? What is the impact assessment of these things? If we build something in here, how does it affect our local environment? And of course, money. And money is a big thing as well. And here are just some figures that show, for instance, using numerical models or like atmospheric model in the top here to simulate a different cyclone. These are different cyclone tracks in Europe. Down here, for example, we have some storm surge simulations we have in the past here, historical storm surge, and under future. So how does the storm surge change in the future, for instance? And there are many different solutions as well. We have soft measures, for instance, erosion. Oftentimes this is the preferred way, and because it doesn't have any artificial or human interference. And it tries to use natural materials. So we have beach nourishment, for example, more sand in the beach. We have dune restorations, because oftentimes people build things on the dunes and they destroy the dunes. But the dunes are very important sort of buffers and delicate systems. And vegetation planning regulations is very important. It's like not building next to the coast or keep the human activities away from there. And managed retreat and some other ones as well. So soft measures are like non-structural and they are based on the sort of like a nature-based. There's also hard measures, and so again, the choices usually depend on the needs. And some examples in here are, for instance, groins. We also have jetties, we have breakwaters, and the idea of these things is to also stop the erosion in some locations. But the problem with this is sometimes people build those things and the problem is fixed in this location, but it's just shifted to another location. And some example, or like a good example from this is oftentimes we see from these tropical resort towns as well, is when the beach or the sand is just going away, it's being eroded. And then they decide that, okay, maybe location A, number in here, is we build a jetty here. And the jetty idea in here is to sort of trap the sediments. And from these figures you can see that, you know, there was a sandy beach in here before. Then 3 years later, we have here is the jetty and how quickly the sandy beach is disappearing on the sort of downside of the currents. But they have a bigger sandy beach now in this side. So location A has a very nice beach now. Location B, there's no beach. So it's very difficult, and it's very important in terms of planning and designing these different types of structures. So you can't solve the problem only in one area to put the problem into some other area. And for flooding as well, and these are usually in higher risk areas, so where we want to protect some specific infrastructure from floods, humans from the floods, and they're much more expensive to do. But some examples are sea walls, there are revetments. Here's an example of a revetment, what it looks like. We have embankments and even sometimes like a smaller parapet walls, we call them. And this one here is an example actually in Tokyo Bay. And this is a seawall in here that was actually destroyed in 2019 with Typhoon Faxai. And you can see that it was actually destroyed. So it doesn't always guarantee 100% safety. But they do immensely increase the chances of a good protection and safety in those areas. And another example here is, for instance, super levees, and this is in Tokyo. And these are massive mega projects. And the idea of a super levee, for instance, you can see the difference between ordinary levee and here is a super levee. So big areas of land are being elevated and the new structures are being built on top of it. And the main idea of this is if something does happen with earthquakes or floods, and if the city is below mean sea level, then it becomes a problem there. But super levees really help with that. And for the summary in here, we just talked about a little bit coastal engineering, what its fields, and the climate change aspects of coastal engineering and some of the solutions we have against protections or how to adapt and mitigate different types of problems. And next time we'll talk about a little bit more is adaptive coastal design framework. And this is specifically designed for considering climate change in the future with sea level rise and etc. All right, thank you.